Alrighty, let's take a look at using ChatGPT to learn Python for QGIS, otherwise known as PyQGIS. And I'm just going to record myself. I do have the pause button here, the Alt-T, if I need to. It's supposed to work. What happened here? Oh my, didn't work. It's supposed to work. It's supposed to be this. My bad, it's actually Alt-Y. That's what I should have used, so if I hit Alt-Y. It pauses, and then if I hit Alt-Y again, it unpauses. Okay, so I'm in here. All right, so I'm asking ChatGPT 5 about the way to make a quick QPy map. And it's starting out, it's telling us to set the CRS. So this is a new project. So we go project, new, and we have that. And then come down here, and there's the CRS down here. And it says to use 3857, which is pseudo Mercator, and say OK, and then that appears down here on the right. And then it tells us to, we could have gone project properties, CIS. I guess we could have gone project and then properties here, and then we would have picked the CRS coordinate system and applied it. All right. So we've got that. The next thing we would do is add a base map, and we're going to use data source manager XYZ add OpenStreetMap. All right, so let's do data source manager. Do we even have a data source manager? Because usually I use the quick map services, but it's not telling me to do that. It's using, in this case, it's saying layer data source manager. So we go layer and then go data source manager, and then from there we would use XYZ, and then OpenStreetMap is there as the URL. So if we add it, something should happen. Right? Oh, we added it twice. Close this up. There it is. I don't need two of these, obviously, so this one gets deleted. Remove layer, and there you go. So I've got that. Then it makes a suggestion of using an Esri map. So it says to add an imagery base map, and I guess they're implying that you could use layer data source manager for that as well, and look for an Esri map, which I do not see here. That's XYZ tiles. This is ArcGIS Online, but it's not telling us that. So where would Esri be in here? Vector tiles and connection details. So there's connection details here using that URL, but it's not telling us optional add an imagery base map as well. So hold on while I look. Well, actually, let's do it the way we would do it. Let's just ask it. Let's see. How did you want to add the imagery Esri layer? You didn't specify. And it says it's thinking, and sometimes it takes a few seconds. Thinking always does, right? So this is a good time to pause. All right, so it's saying go to data source manager, do XYZ connections, which we have, and say new. So you click on it there, and then from there you would put in the layer. Now, it may be that it's already available from this drop down up here. Yeah, Esri XYZ tiles. So I didn't have to use. What it was going to suggest is that we use this server ArcGIS Online imagery map services, and it's right there, and that is what we see up here. So it already had it built in, so we don't have to worry about that. So let's go back up, and that's the whole thing about using these programs. You need to know where to click, and sometimes it didn't seem obvious, but we have that, and then we add that map, and it came in, and there it is. So you can see when I open this up there, that's the OpenStreetMap under there. And there's the S3 tiles there. All right. Let me save this, of course, because we always need to save. I'll save this as QPy tutorial. Right. Now, our next procedure is get the elevation. If you have a DEM, add it now. Add raster. If not, use a plugin, STM downloader or Aster ALOS via Open Topography plugin, any 30 meter. And I do have the Open Topography, I do believe. So I should be able to go to raster, DEM, Open Topography. So this is a plugin, by the way, that I got. And I got that plugin by going to plugins and doing manage and install plugins. And that then I went to Open Topography and there it is, the Open Topography downloader. So this is what it gives you. And I put that plugin in. I don't need to do it again. And having that plugin now, when I go to raster, I can go to Open Topography DEM and just drop that in. Then I have to pick a region. Is it going to tell me what region? Any 30 meter DEM. Wow, that surely load your places of meaning. I mean, if I did the whole thing, it would really gum this thing up, I imagine, but we can try it. Okay, so define the extent. That's the whole map, I guess. And we do the 30 meter. But I would imagine this is going to crash the system. I'm not sure. We'll find out. Save to file. Say world SRTM 30 meters. Whoa. Put that in GIS. Alright, so good luck. The maximum area is it's too big. Select areas 4 million. Oh my gosh, look at how big it was. So the maximum area is 450,000 kilometers squared. So we have to pick an area that we want. And the best thing to do here is to zoom in. I really want to find Krems, Austria, but I don't think I can find it using this. Krems, no, there's not going to be anything like that. One thing you can do if you don't have a clue where things are is go to maps.google and I'll say IMC Krems University of Applied Sciences, and there it is. And then I'll right click on it and take the lat long, because you right click and you get the lat long. And then having that lat long, if I come back in and then I go to locate, I can put the lat long in and then tell it to go to that. And it really chopped me in the middle of the ocean, so that's really bizarre. Let's see if I do it like this. There we go. There's Krems. And the other thing you need to do if you're going to, it's in a different, it's in a different lat long, a different projection. But be that as it may, if we're going to do that, you should change the scale to like 1 in 2500, and then run your query here, and bang. That should be the building. That should be the same building. We can zoom out now. That should be the same building that we saw here. All those beautiful solar panels. So this is that windy thing. If we go back to the S3 image, looks like, did it hit the right thing? Interesting. No, it didn't actually, because I think that we are, let's again go look at our, there's the building, and it's over there to the right. And here we have that building, and over here to the right, I guess. Aha, there's those solar panels. Those are the solar panels at all. There's that part. Let's look again at what we have here. there's that. And then it's interesting, it's not the same location. So let me try this again. Let me grab this and let me go here and let me paste it in and let me, yeah, there's the building, that little thing there. That worked this time. So that's the same as that, evidently. All right, so now if I want to get the topography of this, one thing I always try to do is, if I've got this, I might as well add a marker, and that's not going to be in that tutorial, but let's go to the, let's go and let us add a, faster, but let us add a, add a layer. We'll create a layer. Let's do a geo package layer, and let's call this points. We should find something here. It shouldn't be there. It should be in our shape file. Let's export JS photos. And let's then go to the GIS for Climate tutorial, and let's make a new folder here and call it IMC Crems Geo Packages. Right? And then from there, we'll open that up and say points of interest. All right. So we do that. The table name is going to be points of interest, and the geometry type is going to be here points, and include the z dimension, include the m values if such exist. And the new field that we're going to create is environmental affordances, and it will be in a integer form or a decimal double. Let's do a decimal double, and we won't put a maximum length. We'll go to field and we will say OK. Now that we have points of interest, I can come in here and I can go to the pencil and I can pick these points here, and now it turns into a target. I can put this here and say, oh shoot, right, that's the lat long. So let's put the lat long in. Okay, let me do it. I got to add another field in here. So let me come in here and let me open the attribute table, and let me edit the attribute table by adding a new field, and let me call this name of asset. And then that is going to be a text string. And we'll take that. All right, so now we have that. I'm going to affordances. This one here, I've got to change the name. So if I want to change that name, I go into edit. That's an add field. Let me see if I can edit the field. This is delete field. This is organized columns. That's open field calculator. This is multi-edit mode. This is multi-edit mode. It's going to let me do it. No, do you want to save the changes? Save them. Is it going to let me edit? Let me see. Environmental affordances. Will let me change the name? Not through that. Maybe through this. Maybe through add feature, no. Paste feature. New field, delete field. So I guess I could just delete this field and then re-add it. And I'll call it environmental affordance lat long. And then that can be an integer, or it can be a decimal number. I'll use a decimal. And then I should be able to stop editing that and save that. When I go to place this, point, and click here to make a point, put it here. The name of the asset is going to be IMC Friends University of Applied Sciences, and then the latlon was what I picked up from Google Maps. That there, put that in, and it won't let me paste it in. Okay, that is interesting. Can't account for that, but we'll say okay, and I won't have it in there because at least it is there on the map. There's the point. And when you go to click on that point, so I have to save it and then stop editing. But when one goes and clicks on the point, when you go to info here, then it tells us that it is the Krems University of Applied Sciences. Right. So good enough for there. All right, so we have that point there. Now, how big a part of the region do we want to get the DEM for? Let us right-click here and zoom to the layer. And let's go down to the floodplain here. So this will be our extent. And now we're going to go to our raster, our open topography as we were doing. Go to the SRM 30 meters. And the extent that we're going to do is the extent of the map here. And then output it to our file, which we said was going to be IMC Krems. All right, and call this floodplain DEM IMC. Now, run it and wait for it. And I'll jump pause because this is taking a moment. Nope, it's not. Okay, we're good. There it is. So we can see these are the highlands and this is the lowlands down here for that piece there. Right, so let's save. And now we are where the tutorial from ChatGPT left off. And just letting you know that when we come here, if we go to right-click on properties, then we can naturally change the transparency, and then you can see what's behind it. Okay, and that looks like that's where our location is there, and that sort of matches the topography in there. And just for for fun, you can always go to the 3D map view and go to a new 3D map view. And when you are on that 3D map view, you pull this back, and then you would tell it, going to this little toggle here, that you want to do the terrain as a DEM terrain, and then select the elevation from that floodplain DEM, apply that, and then as you can see, it starts putting the mountains in. Now, why is it so cloudy? Well, because we have the DEM on top. And so what you'd have to do then is take this DEM and drag it to underneath there, so you don't see it anymore unless you were to, of course, toggle off that. Now you can see it, right? That's the OpenStreetMap thing that shows up under there. And then when you go back to your 3D map, it should redraw. There it goes. And then you can see the mountains. Oops, did I make that upside down? Didn't make it upside down. Okay. All right, so that shows us that the university is nestled in under these hills in here, and then there's a highway that goes up between the hills, and the university point is right there. That's pretty cool fun. It's always nice to be able to have a digital elevation map. And if you want to see it more exaggerated, because it is after only a 30 mil. You can go to the vertical scale, double it, and then boom, those mountains really begin to show up. It's an exaggeration, of course. It's not that steep, but it is fun to be able to use the tool and bring it into a higher relief sometimes. Right? You can use that if you're trying to look at risk. You can see then, but through those exaggerations, just how where the water is going to flow. I'm going to put 5 in. Oh my gosh. Yeah, that was extreme. That really gave a quite extreme look there. As if we just suddenly moved to the parts of Austria where the skiing is. But you can see those exaggerations and then get that idea that yes, this bit of the hill here is higher than the others. But that's so much of an exaggeration. Really, we don't want to do that. So bring that back down to 1, and there you go. All right. And what happened to my... All right. So you can do those sort of relief things and see that there's actually bumps over there. And then you start looking on water flow stuff, flooding, because they did have a massive flood in the Danube River. All right, so what does then ChatGPT suggest we do next? Next it says we want to style the DEM for hillshade. We want to put the DEM then back up. Actually, I'm just going to turn off this. You can see the DEM. I'm going to take the DEM and I'm going to set it to hillshade. So properties, and then hillshade is under symbology, which it usually defaults to, and then go to hillshade. And then apply that, and you get that kind of thing. And then default azimuth is 315. Yes, the altitude is 45. Okay. And then, hold on 1 second. All right, so there's the altitude at 45 degrees. There's the azimuth at 315. That's where the sun is shining, creating these downslopes, right? And then it tells us to put hillside on top, set blending of hillside on top, blending mode. Where's hillside on top? It doesn't say hillside on top. I don't see it. Okay. I did put it on top. You can see it, so I don't know if that matters at all. Put hillside on top with it. Blending equals multiply. Alright, there's that. And then opacity 35 to 50%. I thought I already had set that, but where do you do that? 5 to 50%. So that may be under transparency, 35 to 50%. So I'll do 50. Roughly 0.1. Alright. Histogram we don't need. Transparency symbology. Hillside on top. Load your place of meaning. Well, that's what I'd already done. Prepare an CSV with columns. I did. Name, description, lat, long. Add layer. Oh, then it did say to do the EPSG is 4326. Interesting. Choose original font. Switch to 3D. Name new 3D map view. I already did that. Terrain, DEM, your raster, vertical 1.5 to 2 to taste. And then enable your point layer. Try billboard or sphere symbols. Export a WOW image. All right, so it looks like I've already sort of done this, but I have to say, when you look at it like that, let me say okay here. If I go to the 3D image now, there it is. You get these weird blocks, right? Which isn't so pretty. In fact, can I get this thing to move up? Why can't I get this to move up in the screen? Wish I could. What button do you do? Is it Alt button, the Control button? Is it there? It is. It's Control left mouse to move it up. All right. So that's ugly as sin. And even if I go back here and bring in my SView tiles, let that load, then okay. Well, I guess it doesn't show up clearly, so we're okay. Okay, so chat is suggesting that the vertical scale is set between 1.5 and 2. We've looked at 2, so let's put 1.5 in to give it a little bit more exaggeration. And you can see it show up better. And the only thing I felt a little uncomfortable with is when we look at the DEM and it's looking like that, hill shade. I think that I remember doing something here where to make it look a little better, you come in and you go zoom in cubic in and out. I think, yeah, that cubic thing makes it look a little better, especially if you do the, well, that was the early resampling matters or not. But that's more, you know, what you expect to see when you do that. And then, of course, you don't see it in here. If we did bring it over, then you'd see it a little bit more like that. Gives you some more delineation. If we take it out of here, put on the OpenStreetMap, you see the density looking at it like that. So that I think is interesting to look at it like that. And doing that cubic resampling when you're using hill shade. And it's going to draw, there it is. So you use the density lines, and that's more like what hikers use when they are looking at a map in the old days to see where slopes are. So that's much more powerful than the hillside with the jagged sort of edges. So once again, the way that you get to that is you look at your DEM, and when you're in zoom in, then your resampling is not near the nearest neighbor, it's cubic. If you do bilinear, then it's somewhat similar, so it's fine. It's just you don't want nearest neighbor. So bilinear also works. And there's styles you can save. Okay. So that, I think, is powerful. And then if we put the SView down and move this underneath the SView tiles, so that's picked up by the map here. Give it a chance to load again. And we're done. All right. And then you can take a picture of it. If you want to show that that layer has been created, then put your DEM hillside on top, and then look at it, and then you'll see those traditional map lines, which are sort of rendered unnecessary once you have 3D imagery. But there it is. So now you can actually see those lines and get a sense of the slopes. And there is some use of it, because underwater here, I mean, who knew that it slopes down on the banks there, or that there's some kind of slope happening down in here as you go down river. So there are advantages to having that if you want. And then you can export this, so you have a export button, and you can save as an image, which is great. So we can go to IMC, say IMC 3D, so we can get that. Or you can actually export, right? You can export a 3D scene, and that scene, exports, okay. that scene is something that you can bring into Blender, for example. The other thing is you do have the ability to measure stuff. So, see 3D measurement tool, you can go from the top of the hill to the bottom there, and you can see the total 3D distance and the total horizontal distance. You can do a new measurement. You can go from the university. Where were we? We were somewhere. Oh, our point needs to be loaded, of course. Where's our point? Why is our point not showing up? So what I'm going to do to make the point show up is I'm going to go to our points of interest and double click on it, and I'm going to pick something like a big effect with a drop shadow. Apply that. There, that comes in. So now when I look at it in 3D, there it is right there. There's my little. Okay. And so the distance between there and the top of the mountain is, I'm supposed to see the image on top. That's weird. Go off, back on. Let's go to something else. Stop. Let's go here. Now there it comes. Okay, so go from our point of interest and say how far is it to the football field as the crow flies, and you can see that it's 500 centimeters. If we then went through there, we took a path and we went around there, each leg of the path as we make our way out of town is then picked up. Right? And you can do it in meters, kilometers, centimeters, all that sort of stuff. So it's cool that you have a 3D distance that you can do. If you did it from the bottom of the mountain to the top of the mountain, the question is, what did I show there? Okay, so when you look at that, see, sometimes this thing just disappears. So you have to click off of it and then click onto it. And then you can do that. So the bottom here to the top here is 578 meters. The horizontal distance of 556. It's not perfect because you're not really getting a true vertical distance, but it has that capacity. All right, and you can see north, east, and south. You can move around east, move around to the west. You can rotate, turn it like that, and good. All right, so now what ChatGPT is suggesting that we have something to show right away. We could do project. Let's see. Project new print layout. It says, so let's go to project, project, new print layout, unique print layout, title. So call this IMC Programs layout. And say OK. And then from this layout, we would add to it, add a 3D map. Alright, and the scale is not set. Why? Why? Layout. Item property reference map would be copy settings from 3D view. And there it is. Alright, so you have the ability to print out these things. And if we want to add the 2D map in, then we would go and we add item, and we would add a map. And then the map,
I think I know how to do it.
After you do it, you
maybe put up here, and there's the map right there. And we have both of them shown, so you can see it in 2D and you can see it in 3D. And move these things around. And that gives you something that you can print and send to people. Right.
Yeah, now you can mark this.
It'd be nice if I could put a A grid maybe? No, I don't want a grid. A border. But yeah. I mean, there's ways to do it, and I'm not going to play around with it to see how to put borders and stuff like that. Not feeling interested in doing that just now, but obviously it would have that ability. Shape, snap tolerance, layout, margin. Anyway, a lot of stuff to work on there. So what they're saying now is, I might as well save this. Save it. And let's see, there's layout. All right. What is chat now saying? It says, okay, that gives you something to show right away. Now, part B, make it repeatable with PyQGIS, because the whole purpose of using Python is that we are going to automate everything, so we don't have to go through all this clicking and these procedures. So it's the script here is going to center on a chosen place using a lat long you provide now. We'll add geocoding later. Adds an OSM base map, an OpenStreetMap base map. Your DEM makes hillshade. Loads a CSV of meaningful places, creates labels and callouts, sets up a 3D view with terrain and 3D pointables, and exports a layout image, just what we saw. So where do you run it? You go click QI plugins, Python console, paste, run. So I got to go up here and look at plugins and go to Python console. There it is. And click the editor button, which is the editor button. I think this is the editor button. Show editor. There we go. There's the editor. Okay. And now you paste it and run. Minimal inputs to edit the top would be the place, CSV path, dem path, and the output image. So then he gives me this whole code. And if I take the code,
Symmetry.
I guess that's a different one. It's a different code that I had from something else, so I don't need that tab. So there's a new tab, and I'm going to paste this in, and I'm going to call it save as 3D map Python script.
The purple goes here.
And do I have any Python script thing? I'll just put it in IMC so I know it's there, but I'm going to get a new folder for it. I'm going to call it Python scripts. Call pane.
Here?
Alright. We're good. Now, what happens when I run this? I guess the first thing I need to do is get rid of everything here. Alright. So let me take that and delete it. Remove all those layers.
Clouds off.
So I have basically a blank map now. And then when I run this, what is it going to ask for? Is it going to ask for anything? It does the map, and then it says the DEM is not valid or not found. Because in the script, it's got place name, and it's got output image. So what is the script doing? The first thing it's doing is it picked up Krem, so that's good. So it picked that up, Latin long, and then I didn't know how it got those in there, which is fascinating how it even got that. And then it's got meaningful places. So everything I had, it's actually picked up. Edit these. Well, that looks fine. And then you add the DEM. Did the OpenStreetMap. It got caught at GeoPackages. DEM not valid or not found, and that may be because I never saved the DEM. So the path for the DEM would be dem tiff, and I didn't save it as such. I have to see where I did save it, so let me look for that. So I have it here, if I saved it properly. That would have been the TIFF file. And so if I grab this properties or copy as path, and let me go back into my script, and I would tell it to then.
I did it.
So there's that. The thing is that I think you've always got to turn these slashes around from when they do the Windows path, or things get really messed up.
I'm gonna use the color.
Okay, since you use multiple colors, you need to be careful. First of all, after
Maybe this will work.
right? And then
I don't know what this R means here. Oops, I messed that up. Shouldn't have two. Okay, so R and then whatever D is. But we'll try it. And so I'm going to get rid of the OpenStreetMap and let that load again. So remove layer. And then let's run this again. And it doesn't do anything this time. It ran into a problem. Undetermined string literal detected. So maybe it doesn't need path to. Maybe it doesn't need D. Let's try that. Nope, sure doesn't like that. So what if I don't use R? I just do that. Nope, it's not liking that either. Alright, so let me put this in here. This is then where we'll turn to ChatGPT for help. Let's see what we get. Say, hi, ally, getting an error in the Pi console because I don't understand how to modify paths. And I'll put a picture in. Let's see what we get. Alright, so what it's saying is, I thought, is it has something to do with the slashes. And backslash starts an escape. So your path contains backslash. It breaks the string and it can't find it in the file, and then it's not written right. So it goes through and it's telling me different codes that we can use, but it says how to do it, but we can do a sanity check. And then it asks me if I want to browse to the files. So I'm going to ask it to browse. Please browse. Please give me. Files instead. Type in as.
I leave it for Miss Annabelle to do it, okay? I do it with Miss Annabelle because you don't listen. Maybe there.
So let's try. Alright, so I've asked ChatGPT to construct a better piece of Python code for me. And it's still working on it, as you can see. This one should let me just input stuff. I'm still going to have to get the DEM and find my place. But then it's automated, so this can be run again and again and again. You don't always have to start from scratch, if it works. So the prompt to type a place, or accept defaults, prompt to type in zoom radius, file pickers for the CSV, the DEM, and the output image, a styled map. For 3D, open view, and then of course you have to manually open the 3D map. If you're going to auto-open a 3D view and set billboard, I can extend this. Well, let's try what they have first and see that that works. and then we'll see about getting it to automate doing the opening, so we don't have to do any work at all. Because that's really what we're doing here is using automation, and it's funny that we sometimes caution people not to use AI, and then we teach them to code so that they can use algorithms to do things for us. It's pretty much the same. It depends how deep under the hood you want to go. So now when I hit run for this script, type a place. So, okay, friends on the Donald. Let's see what that does. Now map radius F3 will leave the default. Now it wants the CSV of the meaningful places, which I would have had to have created, but once you have your spreadsheet with the CSV, then you can work with that. But did I actually make a CSV for this? I guess not. No, there's no CSV. Select the CSV. Name, description, lat long. Let's try something here. Let's just go into Libra Calc. And let's do exactly what it suggests. It wants something that has name, description. So go name, and then we'll have description. And it needs a small n, I guess. Name, description, and then lat, and then long. Those are the fields that it expects. And the name is going to be IMC Friends. The description is going to be University of Applied Sciences. Lat is going to be 48.408. 48.40880. 48.40880. 48.40880. And the lawn is going to be 15.58885. 15.58885. Alright. And then save this as, and we'll call this, what was the program calling it? Program is calling it CSV of meaningful places. But what is it actually looking for? I could call it that. I could say CSV of meaningful places, and save it as a CSV for sure, and save it in geo packages here. And, okay, and hopefully when we go back here, there it is. Say OK, and then it wants the DEM, which I have here, and then where to save it, which could be saved at there. Alright. Wow, and it just automatically populated exactly that. So that's cool. Of course, it's using it like it wanted to. It's doing the hill shade differently than I would have done hill shaded. And we can fix that later. But now it does say to us that then after we've done that, then you'll have to get 3D yourself. And so, yeah, it would be great now if we can, I'll ask it to do two things. Yes, please, but and you put in the code to set a fill shade to bilinear rather than default, which looks bilinear or cubic, which looks very blocky. I prefer the contour. And then let's automate the 3D map viewing. So let's let that run. Alright, so here's what it spat out. A single complete script you can paste into the QGISPython editor and run. It adds file pickers, so no typing paths, place name geocoding, nominatim, Esri world imagery plus optional reference labels, smooth hill shade via bilinear cubic resampling, goodbye blocks of pixels, optional contour overlay for a contour look, auto zoom plus layout export, auto opens a 3D map view with your DEM as terrain and your points shown as billboards, and then run it in QGIS. So I'm going to copy that code. You can see as it goes through what it's going to do. First it imports packages, has the coordinate reference system and the QGIS project, so it sets up all the stuff it's going to run. Then it opens file for pickers, imports settings, and then it has some defaults that can be overridden by the geocoding. I'm picking crems there by default, and then it lets us, I guess, enter what we want, maybe, I don't know. And then as we go down here, it browses for inputs and outputs. It then has a project CRS that it sets, 3857. It adds the base map. It brings in the Esri image. It brings in DEM, if we have it, which that we'd have to get. And then it does contours, and then it brings in the CSV, and then opens up the 3D map view. So it applies cubic when zoomed in and bilinear when zoomed out. There's a bit of oversampling, that's what removes the blockiness. Contour overlay is optional, we skipped the processing framework, isn't available. And then the 3D API has minor differences. This wraps that section and try accept. If you support it, most do. The window opens already configured with your DEM terrain and 3D points. Or with a friendly note, you can set the terrain manually. If you want the 3D to start at your chosen extent and tilt the camera, tile camera, tell me your QGIS version, and I'll tailor the exact commands. All right, when we get to that, let's copy this code, and let's erase what we have here. So goodbye meaningful places, so all 4 of these, and we're going to remove them. We will come up here and select all of that and delete it in our new code, save it, and let's run it and see what happens. So it wants a place, so I'm going to put M's on the tonal. And then it wants the map extends, and then it wants the CSV, and then it wants the DEM, and then it wants a place to output that, and then it's created it with the requisite stuff there. Now, it is giving us a so when we open up the 3D map, what happens? It automatically open the 3D map or not? Well, there's our point of reference, but it doesn't have the other stuff toggled on. Why is that? See what it's doing in here. it doesn't know where to get the elevation. Interesting. Yeah. Did pick that, so that's not it. It's just it doesn't have the other layers for some reason. And it's saying an expected member of label placement. So it got stuck before it did everything. And let me close this window out. So when it got stuck, type error. That's what we're going to have to show ChatGPT that it got stuck here. So let's grab this. Here's the error we got. We love that. First got these errors. The 3D app only showed the paste that in and see what it comes up with. Alright, so it's saying to me couldn't open a file, so it wants me to, easiest fix, don't force a placement, point layers label fine with defaults. Replace this, the label section with this. So we go to the label section and fix our code. Let's see what the label section is. Maybe if I do Control F, I can put in the label. Yeah, I did not mess that up, so I don't want to do that. Okay, what if I do that? Okay. Label section. Where's the label section? Is that the label section? Here. Label. Well, there's a lot of things that have label in it. So, where's the label section? New reference labels. I'm going to have to look in and see what it means. So the label section, where's the label section? Labels. You know, this is where, to try to figure out how to place this in right, I always make errors. So this is where I'm going to ask ChatGPT to just recompose this. And I'll tell it what big version I'm using. I'm
not done with it yet.
Okay, so I'm going to tell it
Because I didn't.
I'm using, can you give me the full script with these improvements?
Blue yummy sauce. Blue yummy sauce.
Okay. Alright, so now we've got a new version, so let's get rid of this, let's paste this in, and let's save it, and let's clear the console here, and in addition to clearing the console, let's get rid of all these, and that gone, and we should also, yeah, there's no 3D view yet. Alright, so now let's hit this and see what we get. So place, once again, ends on the pronoun, and then the radius is fine. Got meaningful places script, got floodplain, and have an output. It comes up, which is nice. Alright. Now, did it open the other 3D window? No, it did not. Okay. Alright, but it gave us this traceback problem. So we're busy processing something else right now, but let's just see what happens if we had to manually do it. It's a weird DEM. So it's got a reference of the boundaries it brought in. The S3 world imagery is there. Contours show up, and then the meaningful places is IM supremes. It has a label, which is great. When we go to 3D view, turn that on, and yeah, it doesn't have the elevation.
Where's the one? Oh.
So it clearly doesn't see what it's supposed to be using for some reason. That should be DEM, and it doesn't show anything. Alright, so we're having a problem with that aspect of it, with the DEM. And it is obviously the right DEM, but it's not working. Oops.
What did you go with the B?
So we're going to try it again. Runs on there, go now. The radius. CSV. Floodplain. First rows. Name the column for left. Name the column for lawn. And some labels. That's cool. Right, so the only problem we have still is this 3D map Python script. Because it's small, and if we go and look at...
Is this wrong? Mike, is this wrong?
If we say new, let's manage the 3D map views, and let's get rid of this. And then let's go through it again, and it could be that there was one already in there and that created a problem. New 3D map. So we can see that it's bringing in the DEM. So the DEM is not really the issue. Although, that's going to do that. So we're getting that, but we're not getting the imagery in there. And that's not usually how this thing works, because this thing usually has the other parts of the terrain in there. Maybe we need to do map canvas extent and apply that. No, it doesn't do a darn thing. The terrain is usually pulled off of there, and then the terrain is not doing anything there. So usually it pulls off the other layers because they're on. And if we bring this underneath there, maybe that will work. Let's see. And putting the DEM underneath. There it is. Ah, okay, so that was it. So the code simply isn't adjusting the layers like it should. And if it did, then you would have, well, we don't know that because I ran that myself. So let me tell it code works for 2D, but doesn't open the 3D map layer, and when I open it manually, because the DEM is on top in the layers stack, we don't see the S3 terrain. Can you make it so that the DEM layer is on the bottom and that the 3D viewer sets to a DEM terrain radical? The error message in the console is, and let's see what this comes up with. You're going to spend a while working with your AI ally to get this all worked out, particularly if you're someone like me who doesn't know Python at all. Alright, so I have a new piece of code because I complained, and it's a much longer piece of code, but it's going to put the DEM as I requested at the bottom of the layer stack so the S3 image stays visible. It's going to hopefully auto-open the 3D map with the DEM set as terrain, 2D map draped on it, and fixes that layout deletion crash, making a unique layout name and adding it to the manager, keeps the CSV side field picker. So we'll copy that. It tells us at the bottom of the code that it just repeats what it said before, no more wrapped C++ object deleted, and then we'll try it for my machine. And part of it, the problem is always that we're dealing with different versions, and so we're sometimes limited by how QGIS rewrote its version. So I'll clean this part of the Python console out. I'll take this Python code and delete it, and now we'll go and put this Python code in and save it, and make sure that we don't have anything going on in the 3D layer. So we're going to manage the 3D map views that we had and delete that one. And now, with a clean slate, we're going to run this program, and we're going to type in then we are going to do the map extent, which is fine. We'll pick our CSV. We're going to pick our DEM. And we're going to tell it that we want to put the lat column there, and the lon column from there, the name column for the label. It thinks it makes this image, picks IMC parameters, which is great. Yeah. Okay. Now, the DEM should still be in there. There it is. There's our DEM. And yet it didn't open the 3D view. Did it even make it? It may not have. Didn't do it. So something is going on. It isn't able to create the view. Obviously, I can make the view myself, but then I've got to go in and choose the DEM and the elevation, and then apply it, and then yes, I have my 3D view. And I would also want to exaggerate it to 1.6. More exaggeration. But did it do it itself? No. So what do we have here? Well, what we've been able to automate so far using Python is a Python script that lets us create pieces of map. And if we run the script again, so we've already got this based on those inputs. What happens if we keep this 3D map Python script and run it one more time, but this time we say that we're going to use Po France. And say, okay, same radius. Now the problem here is we don't have Po in here. And it's going to be looking for just one field. So I'd have to have a new file that was just for Po. So I can't even put it in here because how would it pick? It would be nice if I could have in here Po France and actually say Eclore University and then put in the lat-lon of that, but I'm going to have to get the code rewritten, and I'm going to ask chat about that. But let's figure this out. So if I do put in Eclore in Po, I do believe I'm in Po right now. Yep, I'm in Po. I think I'm in Po. No, yeah, Po. Okay, so if I take this lat-lon and I put it in here as this, and then take this out, cut it, put that longitude there, make sure I get rid of the comma. Okay. Right. So that would be Po, France. Now, let me save this. So if I, in my code, I'm going to say, okay, what if, oh, first of all, first, the code doesn't open the 3D view at all. Second, and most importantly, what if I want to use the same CSV for several locations in the world of significance to me? How would I select Eclore University from my CSV rather than IMC? I've put IMC in the first row and Eclore in the second. So hopefully it's going to give us a way to select rows. Let's see. All right, let's see if it has done what we want to. Multiple places in the same CSV. You can pick the CSV and DEM. And of course, the window tells me what happens, any message box, self-permission version. So I'd have to create, I mean, here's the thing. Before I run this, so I'll take this code, which is great, and I'll come in here. So I've got to replace this code, obviously. So I'm going to get rid of this and go there. And I'm going to need a DEM of Po. So for me to do that, I have to have that prepared, and I'd have to know how to do that. So I've taken this here, and I'm coming into here, and without using the code at all, and by the way, I do have to get rid of this 3D view, I have the same map. I can keep these already on the map. I mean, that's fine. There's a whole world map there. But I need to go in and find this, which is Poe. There's Poe right there. And then I need to zoom in my scale to there. Maybe I should go to it again. Oops. So there it is. I don't know why the S3 is not letting me come in on Poe. That's sort of weird, because normally you'd be able to come right into it. And it's not letting me find it. Obviously, I can go to meaningful places here and zoom to that layer, and on the Krems, why not Poe? So what's happening with this? I come in here and I tell it to go to the coordinate. It shows up there, but no map comes in, which is kind of strange. Maybe it's because, well, there's no real reason. Because if I put in a, yeah. All right, the problem was that there was just no internet. So that's why we were seeing that problem there. So if I go here now that there's internet, we should have something. No? Maybe not. Let's see. There, okay, so now we're on Explore University here, and we would want to get a digital terrain map. Nice if we can get all the way down to the river down here on Explore. All right, so having that, we would go to our raster and our open topography downloader and pick our SQM30 and define it by this map here, and then output raster it to a file which would be so now the thing is it's already made for IMC, so I'll just do explore floodplain Poe and say that one. It'd be nice to automate this with Python as well. But this script now should let us pick it. And there it is. There's the IMC floodplain right there. It is on there. And so we should now be able to take this out of here. And we can go back to the Krems place. So zoom to layer. So that's where we were, right? And that was the DEM for that. And now when we run the new code, which I have to make sure I'm using the right code. So copy this code and let's erase this part here. Save this. So this is the new code, and we're starting in a different part. We're starting in Austria, but this time when we run the code, we want to add another university. So we run it, and it's going to ask us for the CSV. The code now should let us pick. Oh, it didn't. So this is weird. All right, so there's a chlor. So we're going to pick that chlor this time. And now the lat column is what we want for lat. The long is what we want for long. The name is what we want for name. But pick a place. So we're going to put in a place from the CSV, and we're going to use either a chlor or IMC. This time we're going to use a chlor. And say OK, and then put our radius. All right. And then the output map. So now, boom, we're right there, and we have two DEMs. We have the so there's the chlor is on the top of that. That's interesting, but it didn't open up. It didn't open up at all the 3D map like we thought. we go to 3D maps, we go to 3D map 1, we're still back in Krems. And if we can even get this out of the way, this looks like it's just stuck. Why is this stuck? Can't get out of it. So let's go to the layer, to the view, and do a new 3D map. That's still Krems. Based on what? So it's trying to get like this massive world map of Europe. Because it's picking from everything that we have here. Instead of picking from, so that's huge, there's France and Austria in there. So that's not what we want. We want to pick from the DEM where we're using the second DEM. And I think that it's confusing these things. So we have meaningful places, but they don't have different names. There's a core university. We want to get rid of this S3 imagery and this S3 imagery and this DEM and this meaningful places and this contour. If we zoom in on that layer, but we do it at a scale of 1 in 2500, then zoom to layer, core is there, way over there. If we look at, yeah, the DEM didn't come in right at all, but if we did that, we should see under 3D map view, it's getting confused. And it may be getting confused because we have too many maps. So let's remove that. And let's remove this. And then let's open up a new map view. Let's detach it. And that's not doing anything here. So let's get rid of that. Let's get rid of this. This should be a new 3D map. New 3D map view, sorry. There's Pro there. Right. And again, we have to tell it not to be flat terrain, but base it on the DEM. And it's not giving us a DEM. Maybe I'm using the wrong DEM. So let's try the other DEM, which is this one here. Yeah, that sometimes happens. Sometimes. Oh, look at that, so tiny. What happens if we exaggerate this vertical scale by 3? No. It's showing that it's not, clearly not a good map. What is this? That's the floodplain one. So if I delete this, and I come in here and I say that I want to get a slice of this, And I tell it to go to topography, select the 30 meter, select, we do the draw on the canvas, tell it I want this is what I want, and then save it to Poe and overwrite that, then run it. And then if I zoom to that layer, and look at it without SVO imagery, okay. If I look at a 3D view with that, call it the Chlor floodplain. That's what we're going to use. And it's just sitting there, which happens sometimes. Yeah, sometimes it just sits there. Sometimes it doesn't. So once again, let's try 3D map view. Let's manage these. Let's get rid of this one. Okay. Close. Try to do a new 3D map view. And there we go. It came up, but it didn't come up as having any kind of terrain. Okay. And when we go here, go to the DEM, pick the floodplain, say apply, but clearly color is okay. Okay, that's a little more promising. Oops. But we don't have any exaggerations, so let's try 3. Still not a lot, there's a little bit there. And let's try 5. And that's sort of impossible. The river does not go up and down. So it's not using the right orientation clearly. There is a big problem there. If we use the DEM, we get all of nothing. Alright, so we're running into some problems in visualization here, certainly. There is another, it did say that there was a problem here with the layout, so 3D is causing us problems, but otherwise we are getting the correct floodplain working in here. There's another program here that does 3D, which is another plugin. It may crash, it may not. Let's see. Oh, it crashed. Alright, so we crashed QGIS. We overburdened it. Certainly, that's something we have to worry about. But we're getting closer to a code with Python that lets us select various things. I think the thing now is to ask it to write a code. Rerun. You can rerun to make a second export center MC. Alright. Thanks. We crashed QGIS playing with the 3D viewer, which wasn't working well at all. can you make the code pull the relevant DEM from open topography as it runs and then stores it in the folder for later use, so we don't need to create a DEM and then run Python. So we're going to ask for that, so we can do that. But going back to what we had, as you can see, that brings us back to Krems. It's the last thing that we had. That was working fine. And how do we get rid of that? Can't get rid of that, right? We can go back up to the 3D map views, manage them, and get rid of 3D map 1. So we have this running, and then when we go back to the Python window, how do we find the window for Python? Python window is, well, this would be nice to know just how to get to our Python window. This is where we left off. Processing, no. We're using the layer view. We're using view, and we want to go to Python view here. Python view, I think, is in the Python console right there, plugins. Alright, and there's the console, and then we want the editor. That's the editor. Oops, I should have. What is that? Let's do it again. Python console. Docket. Come on. Hello, Docket. Docket. Yeah, Docket. Now, editor comes in there. There we go. And yeah, this was supposed to enable us to be my last code. I want to download. Okay, so we have a new code that we're writing. It can't be done. Can it? Maybe. Maybe so. Alright, let's try it. So we're going to get rid of this. We're going to paste the new code in. We're going to save it as 3D map Python script with DEM. Okay. And we're going to run it. We're going to get rid of all this, I guess. And rename. Remove. Alright, so here we go. We're going to run it. And it says S3 reference bound. Okay, something went wrong here. This doesn't even look like it's done. Yeah, it can't be done. That's a problem. So what is it giving us? Maybe it wasn't done running. Let's see. Let's try this again. And save it. Alright, here we go. It wants the CSV. And it's doing that first, and it's saying choose lat, and choose longitude, and the label column is the name, and we're going to pick from this CSV, we're going to pick a core this time, over there, create a folder, select folder. Oh, that's nice, that's a nice feature. So I'm going to say new folder, DEM files from Python script. Let me try that. So folder, that's nice. Then a place to save the 2D map image. say new folder saved to the apps from Python script. Okay, script. Okay, good. And then let's do it. Nothing so far. Nothing so far. Huh. Didn't do it, okay. Told it to do that. Told it to do this. Maybe that was supposed to be a drop-in. I think that's a drop-in. I think that it didn't do the whole thing. I think yeah, something tells me that this is not the full script. This was just a piece. But back to the drawing board. This script only asked for the CSV locations and then gave these runtime errors. So I'm going to have to go to the console and tell it, see what it can come up with. And let's wait for it to analyze. Alright, so it seems the problem was that the open topography needs an API key and it didn't ask for the API key. And I normally have it in my, when I go to my raster and I go to open topography and I go in here and pick this, I have my API key right there. But I need it for this code to work. So I thought it would just have it. It doesn't. So we'll come back here and copy the fixed code. And this time, this is the console. We can clean the console. Let's go over to the script. And let's paste in the new script. And then let's save it. And then let's run it. And now it wants the CSV. And it's going to let me pick the lat column and pick the long column and then the name of the label and then where I'm going to choose between IMC Crems and Eclore. I'll choose Eclore this time, and then it's going to cache the files in the right place. Okay, good. And then it's going to cache where it's going to save the maps. Now it wants the open topography key, so I'll put, oh, that's not right. Okay, I need to find my key. Leave blank to skip and choose a DEM manually. No, I don't want to do that. That's cool that it has that. But my open topography key, I guess I should be able to get it. Topography API key. So once I've logged in, I should be in my open topo. And I do have my own address. And log in. There's my API key. Come back into the script. Paste that in. And now, let's do it. If it's just frozen, or if it's looking. There it goes. Okay, so it picked it. Alright. And it did a DEM, we think. Let's see. No, not really. Oh yes, maybe it did. Yes it did. Yes it did. Yes it did. Okay, good, good, good. So So those are contours. Where's the, there it is. Nice, it's got a DEM. Nice, alrighty then. Now what it didn't do, apparently, is it still didn't give us any 3D. So it's got some attribute error. Okay, so if I do here, if I go to the 3D map view, there's the DEM down there, in there, but it's still got to be picked from flat terrain to the DEM downloaded. And what is this showing us? So if we come here and go to 3, I see it. So there's the mountains up there, and then there's the downs. And it's not a very big image, but it is working. It just isn't opening up that. And if we run it again, because we've put this stuff in there, we'll deal with that in a second. So if we run it again, we should be then able to then go to CSV and also add to it a chlor, not a chlor, I mean crems. So lat long label column's name, and this time we're going to pick crems and say OK. Select folder, select folder. Now the API key's already in there, so once it runs, if it runs properly, yes, all right. So that's put crems in with a DEM there. It's hard to know because it doesn't give a unique name which one is which, right? So we have to let it put names in. Turn off this and turn off this. That's the DEM. Turn off the contours. Right. So it's doing a much bigger DEM, obviously. And then if you do the 3D view there, we have to make a new 3D view, I think, because that one there is Poe. And so if we wanted to do a 3D view, so it's still not opening up the 3D view. That's one of the problems there. So we do a new 3D view, and we're using Krems in Austria. We still, according to this, Krems under now, it's really giving us this strange mapping. Because then we would have to say, good, I want the DEM raster layer, and the one I want is, I don't know, maybe it's this one. How do we know? Clearly that's not the one. Or is it clearly it's not the one? Let's see. What if we use this one? No, clearly you can't do that. So it's the wrong one. So this one is the one we want. Right, and then we'd have to do like 3. Yeah, okay. So it's not using the 30 meter, it's using the 10 meter, but at least in the 90 meter. But it's working. So our code that we've been working with now, while it's still having trouble opening stuff, is very promising for being able to go around and find the different Fulbright locations that we want, as long as we have input them in a CSV table first. I like where it's going. I like the fact that it's replicable. I like the fact that I can go to meaningful places here in Zoom, and it ends us up in IMC Krems. If I go to this meaningful places and I zoom, it takes me to Poe, which is down here. Evidently, when you do the zoom, you need to be in 1 to 2500, and then go and say, I want to be zooming to the layer, and you'd have to do it at scale. So that gets a bit messy. you're supposed to pick the size of the layer, 205,000, and then zoom to the layer. Oh, wow. So it's, yeah, it's not zoom to layer. We're having zoom to layer issues the way that the layer is written. Because you should be able to come right in on it and zoom to the layer in that, but it's like the whole layer is selected because of meaningful places, maybe. Yeah, it's I can zoom to the DEM, and there I'm in code, and I can zoom to this DEM, and then I'm in crems. So there's some work to be done with this, but we're getting there, and that's all for now in terms of making this video. I'm going to ask ChatGPT to explain the Python, and then we know what is doing what. And I think it's like right in here, look at this, 30 meter, 250 meter download code. Somewhere in here, it's the DEM type. The API key is requested, which is fine, and then it stores it. But in terms of the size, we're not getting, there's a fallback and a primary. It's supposed to be primary at 30 meter. Something is a little bit off here in the code. But we're getting there. Great. Catch you later.